This is section 6.5 of Honors Algebra 2, radical equations. So a radical equation is an equation in which the variable is underneath a radical of some kind, a square root, a cube root, a fourth root, whatever. The variable is underneath the radical, it's a radical equation. Like the square root of x equals 3, that's a radical equation. How do you think we would solve the square root of x equals 3? Well, we need to get x by itself, so that means we need to get it out from underneath a square root. So how do we undo a square root? The only way we have of undoing a square root is to square it. Squaring a square root cancels out the square root and gives us just x. But if I square the left-hand side, I have to also square the right-hand side, or the equation is no longer the same. Now, why am I allowed to square both sides of an equation? Well, I'm allowed to multiply both sides of an equation by the same number. Squaring is just a form of multiplying. Squaring means I'm multiplying by itself. So I'm really multiplying both sides of this equation by itself. That's why I'm allowed to square it. And I'm allowed to take an equation to any power. I could cube both sides. I could raise both sides of the equation to the fourth power. Here I want to raise it to the second power. I want to square it so that I cancel out the square root. Squaring 3 on the right-hand side gives me 9. So my solution set is just 9. I should always check and make sure it is actually a solution, because like with rational equations, anytime I'm multiplying an equation by a variable or an expression that contains a variable, I'm possibly introducing things that appear to be solutions but really aren't. So I have to check and make sure 9 is a solution, but it is. The square root of 9 is indeed 3, so it satisfies the original equation. So my solution set is 9. So here are the steps to solve a radical equation. Isolate the radical. It means get it by itself on one side, so there's nothing else on that side. Undo the radical by raising both sides to a power that cancels out the radical. If it's a square root, you're going to square both sides. If it's a cube root, you're going to cube both sides, and so on. Solve for the variable. Check for any extraneous solutions. Here's a whole bunch of examples. Example number 1. Solve square root of 2x minus 1 equals 3. So I've isolated the variable. It's by itself on the left-hand side. I undo the radical. I undo a square root by squaring. So I square both sides. Squaring the square root of 2x minus 1 just gets me 2x minus 1. Squaring 3 gets me 9. I solve for the variable. I add 1 to both sides, so 2x equals 10. That means x equals 5. And I check for extraneous solutions. I make sure this is not extraneous. I make sure it is actually a solution. So I have the square root of 2 times 5, which is 10 minus 1. So that's the square root of 9, which is 3. And that equals 3, so it works. My solution set then is a set containing the number 5. Number 2. 2 cube root of x minus 1 equals 3. First, isolate the radical. Get it by itself. So I've got to move that 1 over. I've got to add 1 to both sides. It gets me 2 times the cube root of x equals 4. Our radical is still not by itself because there's a 2 out front. I have to divide both sides by 2. The cube root of x equals 4 over 2, which is 2. Now the radical is isolated. It's by itself. So now I undo the radical. I undo the cube root. I undo a cube root by cubing. So I cube both sides. Cube root of x cubed is just x. 2 cubed is 8. So I have x equals 8. I check to make sure it's not an extraneous solution. So I'd have 2 times the cube root of 8 minus 1. So the cube root of 8 is 2, so that's 2 times 2 minus 1. That's 4 minus 1, and that's 3, which is what I want it to be. So it works in the equation. My solution set then is the set containing the number 8. Number 3. 3x minus 5 square root of x equals 2. Isolate the radical. I subtract 3x to the other side. I divide both sides by negative 5. So the square root of x is 2 minus 3x over negative 5. Now I square both sides. I get x equals squaring 2 minus 3x over negative 5 is squaring the top over squaring the bottom. So 2 minus 3x quantity squared over negative 5 quantity squared. So x equals 2 minus 3x quantity squared. I'm subtracting in the middle, so I have to FOIL that out. I'll get 4 minus 6x minus another 6x is minus 12x plus 3x times 3x, which would be 9x squared. All over negative 5 squared is positive 25. Okay? Now, let's multiply both sides by 25 and get 25x equals 4 minus 12x plus 9x squared. Let's get everything to one side and write them in decreasing powers of x, so 9x squared. And I've got negative 12x minus 25x makes negative 37x, sorry, plus 4. And then I have it equal to 0. So then I want to factor it. So I take 9 times 4, that's 36. I find factors of 36, they add together to give me negative 37. How about negative 36 and negative 1? I divide one of them by 9. Well, 9 goes into negative 36. That gives me negative 4. So I've got negative 4 and negative 1. I divided by 9 on one of them and nothing on the other one. So I've got 9x and x. The number I got when I divided by 9 was negative 4, so that goes opposite the 9. And then the other number is negative 1, so it goes there. I've got 9x minus 1 times x minus 4 equals 0. That means x equals 1/9 or x equals 4. I check to make sure neither one of those is extraneous. I check 1/9. That will give me 3 times 1/9 minus 5 times the square root of 1/9. 3 times 1/9 is 1/3. Minus 5 times the square root of 1/9 is 1/3. So I've got 1/3 minus 5 times 1/3. Well, that's going to be negative 4 times 1/3. Negative 4 times 1/3 is negative 4/3. Okay? But on the right-hand side, I have 2. And negative 4/3 is not equal to 2. So 1/9 does not check out. It's not a solution. Throw it out. We check 4. 4 would give me 12 minus 5 times the square root of 4. Well, the square root of 4 is 2. Times 5 is 10. 12 minus 10 equals 2, which is what I want. So 4 is a solution. 1/9 was extraneous. That means my solution set is the set containing 4. And that's it. 1/9 was an extraneous solution that was introduced by the fact that we were multiplying both sides of our equation by a variable. So that can happen sometimes. We always have to check. Number 4, square root of 2x plus 5 equals 2 times the square root of 2x plus 1. Here I've got two radicals. So if I'm trying to isolate the radical, the one on the left is isolated, but the one on the right is not. If I tried to isolate the one on the right, I'd end up subtracting 1 and dividing by 2, and the one on the left would no longer be isolated. So I can't isolate both of them. What do I do? Well, isolate one of them. We've already got that. Square root of 2x plus 5 is isolated on the left. Let's square both sides and let's see what happens. All right? So square both sides. On the left, I just have 2x plus 5. What do I get on the right? I'm adding there, so I'm going to have to FOIL. Okay? So 2 radical 2x times 2 radical 2x is 4 times 2x. Radical 2x times radical 2x is just 2x, or radical 2x squared, which is 2x. I'd have 2 radical 2x times 1 plus 1 times 2 radical 2x, so that makes 4 radical 2x. And then I've got 1 times 1, and that's 1. I've got 2x plus 5 equals 8x plus 1 plus 4 radical 2x. So now I've got another equation with a radical, so it's still a radical equation, but this time there's only one radical. I can isolate that one radical, square both sides again. So let's do that. Let's get the square root of 2x by itself, maybe on the right-hand side. So I'll subtract the 8x over, combine it with the 2x that's there. That'll give me negative 6x. I'll have 5 minus the 1 gives me 4 equals 4 radical 2x. I'll divide both sides by 4. Negative 6x over 4 is negative 3 over 2 times x, plus 4 over 4 is 1. That equals radical 2x. Okay? I square both sides. Alright, square on the left. FOIL. I'll get 3 halves x times 3 halves x, or negative 3 halves x times negative 3 halves x is positive 9/4 x. Minus 3 halves x plus another negative 3 halves x makes negative 2 times 3 halves x, which is negative 3x. 1 times 1 is 1. Equals 2x. Okay? I'm going to multiply everything by 4, just to make the math simpler. So I have no fractions. I'll have 9x minus 12x plus 4 equals 8x. I'll bring everything to the left-hand side and combine it. 9x minus 12x is... Actually, this should be 9/4 x squared, because I had negative 3 halves x times negative 3 halves x. So 9/4 x squared. So this is a 9x squared. Okay. And then 9x squared minus 12x, and I subtract the 8x over, so the negative 12x minus 8x makes negative 20x. 9x squared minus 20x plus 4 equals 0. Factor. 9 times 4 is 36. 5 and factors of 36 that add together to give me negative 20. How about 18 and 2? As long as I make them both negative. And I divide negative 18 by 9, I get negative 2. So I've got 9x and x, negative 2, negative 2. 9x minus 2 times x minus 2 equals 0. That means x equals positive 2/9, or x equals positive 2. I check. And we check the positive 2/9 ends up working. I'll let you check that on your own. The positive 2 ends up not working. So we throw that one out. Our solution set is just 2/9. So when there's two radicals in your equation, isolate one of them, square both sides. Isolate the second one, square both sides, and solve. Then check for extraneous solutions. You're likely to have one if you are squaring both sides twice like that. Example number 5, last example. 3x equals 2 plus x times the square root of 5. Hey, wait a second. The variable is not underneath the radical. This is not a radical equation. So how would we solve this one ordinarily? Well, we would want to combine like terms. The like terms are the numbers that both have an x with them. So let's say I subtract the x radical 5 to the left-hand side. By the way, you could solve this the way we've been doing it. You could isolate the radical 5, square both sides. But then you're going to be introducing a polynomial, a quadratic, by squaring x. This way I won't have to do that. And I don't need to do it because the variable is not underneath the radical. So if you notice that, then you can do it this way. So I've got 3x minus x times the square root of 5 equals 2. I've grouped the two terms that have x in them together, and I can factor an x out, leaving me with 3 minus radical 5. Just doing the distributive property in reverse. If I want x by itself, I'm going to divide both sides by 3 minus radical 5. It'll give me x equals 2 over 3 minus radical 5. Now I don't like having radicals in the bottom, so I'm going to multiply by the conjugate 3 plus radical 5. You know how to do that now, right? Multiplying across, I'll have 2 times 3 plus radical 5 makes 6 plus 2 radical 5, distributing the 2. On the bottom, I FOIL. 3 times 3 is 9. The radicals in the middle terms will cancel, and I'll have negative radical 5 times positive radical 5, which would be negative 5. So x then is 6 plus 2 radical 5 over 4, which is 3 plus radical 5 over 2. If I cancel the 2 out of everything. So x equals 3 plus radical 5 over 2. And I don't have to check for extraneous solutions here because I never squared both sides. I never multiplied by a variable. Here are your immediate practice problems. 2 problems, 2 equations. Solve them. Please write down the original equations, show all of your work, check for extraneous solutions. That is the end of section 6.5.